Hi Spring fans! Welcome to another installment of Spring Tips. In this installment, we're going to look at Flowable, a BPMN compatible workflow engine that does so much more than just BPMN. Now, I don't even know where to start. This is actually one of those things where I think this installment, this particular video, will just be one of a series because I could talk about this stuff, forever. There's just so many different things to talk about here. First of all, let's talk about what we're trying to do here, what the use case is here. Now, in previous installments, we've looked at things like Spring integration and Spring batch. In Spring integration, you are connecting systems to each other in terms of events. These events are born of real-life events in the real world, and from those events, from the flow of events from one system to another, you imply state. You can draw a picture that shows that data moves through the system from one point to another and eventually arrives at a destination. That's one way to look at the world. You're implying state where there is no sort of world view of that state. You're drawing a picture of otherwise disconnected systems, and so that's one way to architect the system. On the other hand, some use cases, some workloads, some scenarios require that you have the ability to actually lay proverbial hands on that state, to be able to audit it, to be able to look at the history of it, to be able to query it, right? And in this case, it's not just enough to look at the result of the movement of messages, of the result of movement of data through a system and then say, this happened. Instead, we need to be able to say, how far along are we? What remains to be done? And then, more to the point, when you start getting into these kinds of sort of state intense and sometimes long-running use cases, as often as not, it's not just automatic sort of autonomous agents that are involved in the process. Instead, you've also got, as likely as not, human actors, human agents that are involved in the system or that are involved in moving the work forward. And so what we need is some way in these sort of more sophisticated scenarios, of which there are an infinite many, right? A common one is insurance claims. Another one is a sign-up form, right? Think about insurance claims. You've got somebody who wants to buy insurance, but of course there's a process in place, a business process that helps capture it helps validate those who are applying for insurance. They go through this process where then their background is checked, their health is checked, their finances are checked, and the organization does a risk assessment, and based on this, they're able to arrive at a price that then they can then afford to sell the insurance, or in some cases not afford to sell the insurance, right? And this process is multi-step, and a lot of times it might be just very simple. It might be like, oh, well, this person is, young and healthy and no problems at all, and good money, good credit card check and all that stuff. So we can just go ahead and approve that person right away. On the other hand, there might be some situations that require more extensive sort of revision, more extensive research into the case or into the claims or whatever. So in this case, you might have a human being that needs to actually to talk to somebody, that might need to make a phone call, that might need to talk to the applicant. And this process is more involved, but it involves human actors. And this might require even further still more work to be done, right? It might actually create new processes that get spun up in order to be able to arrive at a sort of a risk assessment result. So this long-running process hopefully arrives at a go or no-go decision, and at that point, then you have a whole number of other things that need to happen. You send an email to the applicant informing him or her of the result of the decision to confirm insurance on that person. You send the email, you wait for the person to sign up to continue their sign-up process. You send another email, you wait for that person to click a document or click a link verifying their email. You give them an account on the website. You have to print out cards. All these things, all these long-running steps, and you don't know just by looking at the profile table whether the process is done, right? And you really do need to know that. You do need to know that somebody has done a background check. You really do need to know that this person has been given their insurance policy documents and everything's been signed, and somebody's crossed all the T's and dotted all the I's, and that the user has created a profile on the website, and all these things have to happen before the exchange, the interaction. Oh, and of course you need to collect money, right? All these things have to happen before you can say you're done, that the result of the agreement has been it has been given in a way that both sides have expected, right? That process is long running. It involves multiple steps, potentially over multiple days or weeks or months. And if maybe these processes are actually time bounded, right? They can take longer than an hour, but they could and should not take less than or they shouldn't take more than, let's say, a couple days, right? That's another thing. You might have time bounds on this. So modeling that asynchronicity, the fact that there's human beings involved that are waiting, modeling the sort of movement of work from one node to another in the system and from one person to another person in the system. These kinds of long-running processes are business processes. They map very naturally to the way the business analyst in your organization thinks about what you are doing. And that's by design. Okay, workflow is all about describing the work in an organization, and workflow solutions like Flowable aim to make it possible to describe these workflow processes, these processes that are business critical, in a way that business analysts can appreciate. And so, as often as not, there's a modeling component to this, and it aims to make that model executable, right? Or at least something that could be, with a little bit of finesse, turned into an executable specification. So this is what we mean when we talk about workflow systems, right? Another common example is just a very simple, something you might have, done a million times. I want to sign up for a website. I go to a website, I fill out a form, I put my email. They want to validate my email. They send me an email with a link. I click on the link, and that resets. That when I click on the link, that triggers an endpoint in the website. That then says, okay, good, your email's been confirmed, your account's created, and then you're done, right? Even that simple thing has a few steps involving an automatic system sending out email and a human being interacting at some point asynchronously, potentially in 1 second, 1 nanosecond, or 1 year, right? In this case, it might not be critical that the person click on the link now. They might click on it in a year, and then so what? The account should be valid then. Amazon wants a customer whenever it can get it. It doesn't care if you signed up now and forgot to click on the confirmation link until next year. They're happy to have you next year too, right? As long as all the sort of peculiars are the same and valid, right? Your credit card and billing address, but I'm sure they'll figure that out after you've clicked on the link, right? So that these kinds of things, these dimensions of the process are things that you would model in a process engine, a workflow engine. And there's been a lot of different attempts at addressing this. There's been a lot of different attempts to sort of support these use cases. There was a particularly misguided one called BPEL, BPEL, years ago. And BPEL was a way to describe orchestration. It does service orchestration, and it awkwardly ignored completely the role of human actors in the system. There was no task list. There's no mechanism by which to create work and then assign that work to people in a system. And so this is a bit unfortunate because really, we don't need help connecting automatic. I mean, except for the auditability, that's nice, but we didn't really need help. I think. Connecting services to services. We already knew how to do that, right? What needed to be done is to model or to design the sort of movement of work in an organization with people involved. And so this got to be such a big problem that eventually they created, and I laugh even just thinking about it because it's so absurd. They created BPEL for people, BPL for people, and this was an attempt to sort of address that glaring limitation, right? It's sort of like, imagine building imagine trying to build Hibernate but having no database access, right? There's no ability to write objects to your database. You can't really say it's an ORM without that, right? That's sort of the point, right? In the same way, I feel like BPEL missed out on its one thing. You've heard the oft bantered you had one job. This is that exact scenario. So enter Beeple for people, that's certainly one option. There have been a number of other sort of proprietary solutions, and when I say proprietary, there's Aqualogic BPM and a bunch of other, all these different infrastructure vendors, middleware vendors have their own workflow solution. My journey began with workflow 15 years ago, and I found myself actually 11 years ago working at a company building my own highly scaled workflow engine, because I wanted to be able to support orchestrating work across a number of nodes and integrating people into a long-running process involved in managing the production and movement of video assets in a system. So we wanted to be able to talk about work across multiple nodes, and this is actually one of those things that's more salient than ever, I think, in the world of microservices and so on. Right? You've got these otherwise singly focused, autonomous sort of microservices that might be enlisted in a larger enclosing process, right? So this use case feels very familiar to me. There were proprietary solutions, and I use the word proprietary in this case now to mean just unique, not based on a standard. One of those was JBPM, which is an open source, I don't think it was Apache 2 license, but it was an open source workflow engine from originally from a separate project started by a guy named Tom Bayens, and that project eventually landed at Red Hat, at the JBoss group at Red Hat, which I suppose is now the JBoss group at IBM. And JBPM was pretty dope, and I liked it, and eventually that got for reasons, just leave it there, JBPM 4 finally sprouted some okay Spring support, but that was the end of the life of that particular tree of JBPM. Eventually, the team working on that eventually went off to Alfresco, and they created a new workflow engine. That was Tom Bayens and Yoram Barez, my friend Yoram. They went off to Alfresco, and they created actually they're both my friends, but Yoram is the one with whom I've had the privilege of sort of more often interacting these days. They went off and created something called Activity, Activiti, at Alfresco. It's an Apache 2 licensed open source workflow engine. And in 2010, Dave Sire on the Spring team, he reached out to them. I contemporaneously, not knowing about Dave's interactions, reached out to them, and eventually, Dr. Sire ended up contributing the skeletal bare bones sort of integration for Spring. I ended up contributing Spring integration, the framework Spring integration support for Activity, and working on Dr. Sire's bare bones sort of Spring integration. And then a few years later, back in 2014 or 15, one of those, I went back and I added the Spring Boot support for Activity, and at that point it went from being this thing that was very hard to get up and running in Java code. And that, by the way, is I think a key thing here. Activity, as with JBPM, were designed to be used by developers. These are APIs that you can use as a library. There are servers that you can buy. There's actually infrastructure that you can buy and deploy. But the really sweet spot for me is that I can take this library, take the jars, just add it to my class path, let Spring Boot auto-configure a process engine, deploy a few process definitions, and then I'm off to the races. And I can integrate it I can hang off this workflow solution off the side of my business application, right? No problems. And I can integrate it with all the things that Spring knows about, including Spring integration, including Spring data. I can take advantage of transaction management, and I can do messaging. I can do all these kinds of things that would have been much more difficult to do in solutions from 10, 15 years ago, wherein you had very little control over the runtime behavior of the specification. So Activity was a very interesting library, and I was particularly enamored of it. One thing that was novel about it was that it supported BPMN. Okay, so whereas JBPM supported its own JPDL, a workflow format that only JBPM supported, BPMN was a new specification at the time, and BPMN 2 was a new specification at the time that delivered on something that was sort of the holy grail of workflow engines. Beeple, the one I just finished describing, um, was a way to describe the execution of a workflow, but it had a limited set of things that you could actually do with it. Contemporaneous with that was BPMN, which is the business process model and notation, which, as the name implies, focused more on the iconography, the modeling of processes. That is to say, the picture, the diagram that you would draw to model a business process. It didn't really describe an executable component. It didn't exactly specify how one of these diagrams, how one of these visual pictures of a workflow diagram would map to runtime semantics. And that was a bit of a bummer. So a lot of different infrastructure and middleware vendors provided products that bridged these worlds. They provided products that would let you describe a workflow using visual tools that you could drag and drool, and then that would be mapped to Beeple, or to the subset. A subset of it would be mapped to Beeple, and that was problematic because it was hard to round trip, and because you could express things in BPMN that you could not run in Beeple because it was so limited. And so BPMN 2 fixed that. It actually specified the runtime semantics for a BPMN process. And that, I think, is where things really got interesting. So Activity supports this. It had Spring Boot support. It supports integration with all the sort of common infrastructure with which you may be familiar. And I would say that's a very good start. Well, things move fast in this industry. So about 2 years ago, circa 2016, the folks on the Activity team really, they wanted to expand considerably the focus of workflow. They wanted to go beyond just basic workflow, so they created a new company and a new project called Flowable. And if you've used Activity, then Flowable, which is also an Apache 2 licensed Spring based now. It's now actually end-to-end integrated with Spring. It's an Apache 2 licensed workflow engine, just as before, and it works a lot in the very same way. It has good Spring Boot starters and integration with all the common hooks with which you might be accustomed. Flowable is a new company. It's a new product and projects, and it goes well beyond that. It actually supports case management. It supports decision trees, and supports building dynamic forms based on processes. So it has a whole suite of things that you will find enterprises want, right? It's great for people that want to move documents around. This is Flowable's one of those things where if you're in a bank, if you're in an insurance company, if you're in a government, then Flowable is your one-stop shop for building audit compliant processes. It's absolutely amazing. It's also BPMN 2, right? So it goes well beyond just process management. Today, we're going to focus on process management, the ability to describe a process that has some steps, and then to be able to see what that looks like. That's all. We're just gonna kind of build a simple process with Spring Boot, and we're gonna ignore for now these other capabilities. Like I say, I think we might end up doing other videos, if not now, maybe tomorrow, right? Maybe next week, who knows? But let's just start with simple. Okay, so I'm gonna build a simple demo here on the Spring Initializer, and I'm going to use the web support. I'll use Lombok, I'll use H2, I'll use the JDBC support here as well. I'm going to use the actuator, and maybe I'll use JPA. I'm not sure if I'll use JPA. We might not have time, but it'll be nice to have that. I might use security. Let's go ahead and add that. And there is no Flowable checkbox, but that's okay because they already have a very simple dependency you can add. And that dependency, that starter dependency, reacts to the presence of these other types. So it'll auto-configure the right things based on what we're trying to do here. So let's go ahead and start that up. Alrighty, it's on its way, and here we go. All I'm going to do is I'm going to add the dependencies that we need to our application. Let me make this font a little bit larger here for you, my friends. All right, and I have the dependencies that I'm going to use here off to the side. Go back to the build. Now, a word. So I could add Flowable, Spring Boot, Starter Basic, and that would bring in everything. It would bring in the case management support, right? It would bring in the workflow engine, the process engine. It would bring in everything. It would bring in the documents, it would bring in the decision trees, it would bring in forms, it would bring in everything. But I don't want all that. I just want the process engine for now, because as I say, there's an infinite number of things that we could do. So let's just get the Flowable engine. Let's use, I guess, 6.4.0. Okay. Property 6.4.0. All right. There we are. So that's the Flowable engine. And you know, that's most of it. We're already halfway there. We've already got, like, I can add more. I can add a REST API, so you can actually, if you just want to build a Flowable server, basically, a Flowable server is a REST API that you can use to launch, query, interrogate, update the state of workflow processes. Okay, so you can do interesting things there. What I want to do is I want to actually build a process, and so by convention, if you build a process and you put it in the source main resources processes directory, like so, it'll automatically install that process in the process engine. What process engine do you say? Well, the one that's going to be auto-configured for us by virtue of the fact that we've got Spring Boot starter process. Where is it going to auto-configure? It's going to talk to a H2 SQL database. It's going to store the tables that describe these processes and their histories in that database for us. And if we had configured a SQL database using regular Spring Boot isms like spring.datasource.url, it would instead defer to that, right? So we can actually see there's flowable.mysql. There you go. You can see there's Flowable configuration files here for the schema that you might want to use, right? So Postgres, right? Everything's here. So that would just get installed automatically. So, really, you're already done. You've already got the hard part done. This used to be a much more difficult thing to do with JBPM. It used to be more difficult in the early days with activity. The fact that we've already got a working workflow engine at this point is really nice. We don't actually have the REST API. Like I said, I've chosen only to have the process engine, not the REST API, not the Hibernate and JPA configuration, nothing else. So I'm just going to go ahead and comment out some of the stuff that we don't need just yet. Okay, and let's take a look at what this brings in. So click on this, and we've got the JVC support, test support, the auto configuration, the engine, testing, and there you go. That brings in a bunch of modules. So you can see these other modules. There's integration, there's the actuator support, there's the process and the process REST API, the apps, the REST API, the regular REST API. I mean, just all this cool stuff. So all we care about right now is just the Flowable process engine. So I will instead revert our change. Okay, there we are. Flowable Spring Boot starter process. Very good. So now let's create a process. I've got a process. It's a very simple process. BPMN is, it's not the easiest thing to write by hand. It could be done, but Flowable very conveniently comes with a nice little modeler here, and so you don't need to write it by hand, and I certainly wouldn't for anything more sophisticated, more complicated. You can see it's very easy to get started here. You just download Flowable's executable Spring Boot wars. They're .wars. You can deploy them to a classic servlet environment container, or just do java-jar, Flowable -idm.war and then Flowable modeler.war, and you'll have. I've got two I've got those two wires running in the background, and with that I have the API and I have this visual modeler, and I can actually model decision tables. I can model forms, cases. A case is, these cases are using CMMN, right? And this in a case, it's a way of, it's not just a process. You can actually, in a case, you're actually telling the engine, I have these things that need to be tracked in the real world, and they are events, and I want those events to result in actions. And one of those actions could be the launching of a new process, but it's more than just the process itself. It's actually more of a stateful thing, and it keeps the glue that listens for things in the outside world. And this is actually, there's a lot more to it. That's why we're going to cover this perhaps in another video. But for now, let's focus on processes. And what I'm going to do is I'm going to import an existing process that I've already got here in the desktop. This is the famous single task process, right? So what do we got here? We've got a task, a user task. Actually, this is a user task. You can see that we have this is a full-featured visual modeling tool. So we have, structural components, we have gateways, we have events, we have swim lanes, we have artifacts. Now let's talk about this. Let's think about this here. Start events. All processes start somewhere, so you have to have the start event. There's different types of starts, so some based on an event from outside, some based on a timer, etc. Like, I want to do it I want to start off a new process every 5 seconds, whatever. You have activities, and then you have, let's see, you have activities. These refer mostly to tasks. So a very common, the ones we're going to use today are user tasks and service tasks. A user task is a task that's assigned to somebody. So you can see it's got the human silhouette, right? The human head silhouette there. And a service task is an automatic sort of thing. It's part of the graph. And this is actually what that is. This is a process graph, right? So you're going to see that the workflow will start on the left. It'll arrive at the human task, at which point there's going to be a list that I can query, right? I can actually programmatically ask the engine. I can say, hey, how many, what tasks for these processes are outstanding? And I can say, okay, well, what about tasks for this process for this particular user, right? So when I launch this process, I can give it parameters. I can say, okay, this is the process for customer ID, 123. And I can then say, okay, process engine, show me how many processes are stuck or waiting at this my task for the user, that I'm logged in as, for example, right? So I can actually, I can say, give me all the work to do for this user in this particular process. And then I can complete it or I can just ignore it. But while the workflow engine has paused here, it saves the state into the system and it's gone. It doesn't move forward until somebody comes along and says, hey, I'm going to claim this task and I'm going to complete it, right? I'm going to say it's done. Who did it? It's Jay Long. It doesn't have to be, you don't have to specify user, but you can. The point is that this is an outstanding task that can be assigned to somebody. You can actually have this show up in somebody's sort of work list. You can draw a screen that shows all the work that has to be done, and then they can do whatever it is that they have to do. They can review a form. They can, upload some information. They can call whatever they want to do, and they can say, okay, I'm done. Or the system can, by virtue of their inputs, say, okay, the task is done, and then it can officially and programmatically call complete, at which point the flow proceeds to the next node in the graph. And this is just a service task. This is just a basic escape hatch. It's just our ability, it's the thing that we use to call some other thing, to call some other code. And what that is kind of up to you. It can be a class, or it can be a Spring expression language expression, which of course can, because of the tight integration with Spring, dereference any Spring bean in your application context. So you can actually call methods on other beans and so on. And then once that's done, it goes to the end state. And so I can actually, this process might take, who knows, right? I mean, imagine this is a sign-up form. Imagine somebody enters an email, and you've got an email and a user ID you've created in the database, and then you kick off this process. And the process is the process of filling out or enriching the rest of the data. Well, you might launch the process and it may never finish. It may never get finished, but you launch the process and you can say, we're waiting on the user to fill out the rest of this form. When they do that, we'll complete it. Once they've filled out the rest of this form, we'll then send them an email over here in the service task. And once that's done, we're done. The user has been enrolled, right? This is a very simple example. Now, you can do some really interesting things here. You can say, oh, well, the result of this form was that we have a new record in the database, which created a new ID, and we've now attached that ID to this process as a process variable, right? So now things downstream, like the service task, can say, oh, I can see the process variable. It's just a string, it's just an ID, a number, and a Boolean. These primitives can travel in the graph, in the process graph. And you can do things. You can say, oh, well, maybe that, I can use a process variable set either at the beginning of the process or at some component after it started. I can use those process variables downstream. I can say, oh, well, based on this condition that I'm evaluating by looking at the variable or by passing the variable to a condition, to a method that does some sort of evaluation, based on that result, I'm going to either go here or I'm going to go there. So I might say, oh, well, this input is invalid, and I might have a sort of a recursive effect where I go back to the first step to collect more input, and I can keep doing that ad infinitum, and it can take years if it needs to. It can take a minute, whatever. And then finally, once this thing says all the data is valid, it proceeds back to this. It sends the email. So you can do that. You can do gateways where you might have this, this task where you collect some information. Once that's finished, you might say, oh, I'm going to set some email here, and I'm going to kick off another flow, another lane of processing, another part of the graph, another branch in the graph, and over here we're gonna send them the fulfillment. We're gonna start the fulfillment process, or we're gonna send them cards, membership cards or whatever, right? You might do two different things at the same time, right? So in this case, you've got a parallel gateway, right? You're starting up two different flows of execution that happen concurrently, and you could go even a step further. You could say, okay, well, this step over here, this branch over here, is not just one service task. It is a whole other process that has to be started. Now that we've gotten past this, I want to kick off a whole new process. So in this case, you could launch what is called a sub process, right? You can actually, instead of having just a little task, you could launch another process that in turn has its own steps and states and process variables and wait steps and all that, right? And so that could be some other process that's designed to whatever. You could do risk assessment, or you could do the fulfillment process. Maybe this process is for when somebody orders something on your e-commerce engine. Now you need to do fulfillment. You need to do, shipping and tracking and credit card verification, all that stuff, right? So you can model very complex things here with these primitives, and the result is a BPMN XML document. So now that you've kind of seen what this looks like, you can actually choose to save this. Just hit save, right? I'm going to hit cancel, and you can work with it that way. Or, as I will do, you can just copy and paste the file into your processes directory. Okay, so there's this. And here's my task. Here's my single task process. And it's, simple example. And this is straight out of the documentation, basically. So let's look at what this does. This says, what are we going to do? This is going to be a simple process. That's a terrible name. Okay. I don't know. What's a better process? We can say sign up process. Okay. Very simple. Sign up a new user process. There you go. Okay. And start. And you can see that when I have a start event, this is the thing that starts the process. It's the first node in the graph. And then I need to connect this node to this node. And I do that through a sequence flow element. So here I'm going to say, the work will progress from start to confirm email task, right? And this will be confirm email. And finally, that task, when that task has been pulled down and then manually or explicitly marked as complete, then work will proceed to the email task. Okay, send welcome email task. Okay, and here we're gonna just send a welcome email, and then we're gonna send that email by calling on a service, a bean in our application context called email service. I'm going to call send welcome email. We're going to send the welcome email to this customer ID with this email, and these variables are going to be passed in. We expect a customer ID and email process variable. Okay, so those process variables are like parameters to a method invocation. So we're going to expect them to be visible for the entire lifetime of this process. Finally, that's going to result in when that email is sent, then this will automatically be completed and it'll progress according to this to end, which is this. So very, very simple workflow process. Nothing particularly fancy. And that's by design. We could, in theory, type this by hand, right? You saw that this isn't that bad. We have a Flowable namespace that's here, right? That's part of the standard. You're able to extend the definition of a workflow, of a BPMN workflow, by adding these namespaces. That's fine, right? And so here we're saying I want to use an expression, and here we're saying that the person that is initiating the process is called the initiator, and we're going to store that somewhere, and then reference that here. Okay, so this is saying figure out who's initiating the process, stash it somewhere as a variable in the process definition, and then here when we say Flowable assignee, I want to dereference that. In this case, we don't have an initiator really. We haven't set up identity management. You could though, and you could actually set the process variable yourself, in which case you wouldn't need that. You could do all sorts of things, but for what we're doing, it doesn't really matter. So let's now integrate this flow into our code. Okay. So I guess I'm not sure. What's the easiest way to demo this? I suppose we could just build a demo, a regular Spring Bean, a regular process demo. Okay. And we're just gonna manually manipulate the API, the process engine API, to drive the movement of this process, to show the progression. Okay, so enroll new user. But it's not hard to see or to understand that you would have these different things happen behind, for example, a REST API or button clicks on a Spring MVC application or a reactive application or whatever. So in order for me to address this, I am going to inject the process engine. Now this is usually a little heavy-handed. If you don't know where to go, you inject the process engine. Okay, and the process engine is the heart of the API. The process engine has a very simple sort of structure here. It in turn gives you pointers to the other interesting objects in the workflow engine, and so you get access to the repository services, which is concerned with persisting the different tables. You've got the runtime service, which gives you access to the process instances. So you've got processes, and then that's the definition of a process. When you launch an instance of the process, that's called a process instance. When you want to get the variables for a particular process instance, you can do so as well. You do all that from the runtime service. The task service is all about interacting with tasks that have been arrived at. Here, for example, I'm going to want to be able to find all the outstanding unfinished confirm email tasks. Right? I can do that with a task service. Identity service concerns how you teach Flowable about users, whether it's through LDAP or Active Directory or Spring Security or whatever. So you've got a number of different things here. You've even got this thing which is fairly new. I don't actually know too much about this one, but because it wasn't really there until later for activity, but this is actually very interesting. What if you wanted to create new dynamic branches of execution while the engine is running, while you've got a process in flight? So keep in mind, this process definition that I just showed you, that's a fixed graph. It's a template that represents a fixed definition of the process. Once it's defined, it's rigid. It's rigid, and it was such that you couldn't really change that dynamically. Once you had launched an instance of the execution, you could deploy a new instance of the process definition, right? You can deploy a new version of this, and Flowable behind the scenes does actually version the process definition. So you can have, 3 or 4 existing processes of version 1.0 in flight for whatever, some definition of in flight. You can do that, but you can launch a new one or deploy a new one, and that will be the thing that gets used in the new execution. So the process engine that supports that sort of that versioning, that's actually part of the runtime service, and that's part of the history service. So you've got other things that do that, but this in particular is if I want to dynamically create new branches in the existing process instance that's running right now. So I can do that. I can use the process engine, but really, for our purposes, we are going to be okay with just the runtime service and the task service. So runtime service. And all of this is possible because we've already got references to the right beans, because the Spring Boot auto configuration does that for us, right? Runtime service, task service. Inject that into the constructor. Alrighty. So we've got a process, we've got a demo, and we're going to launch a. What are we going to do? We're going to create several methods here that launch processes, and again, you can imagine this being hung off the side of a REST API or in response to user. Somebody's clicked on a login form or something. So let's say we've got void begin customer enrollment, okay? And here we've already created the user, but it's an empty user. It's in the database, but there's a whole bunch of null fields. And by the way, that's another thing, is that in these long-running processes, in these long-running tasks, these long-running business processes, one way that we have, I'm sure you've seen this before, one way that people try and solve these kinds of problems is they riddle their customer entities with Boolean, null or not null. Is it fulfilled? Is it, has the user signed up? Has, blah, blah, blah. All these kinds of things that are designed to give you an idea of where in the process the user is. And you end up having to do these complex, if this and that and that and then that, then we are here, right? If this is done, then great. And that's inefficient because you have to check that state at every turn to figure out where you are in the graph. So that process state ends up living in the business entities, but it really shouldn't be there, right? We have a customer, that's what it should be, and it's either valid or it's not, right? But the process state, that should live in the process definition. So here, we can use workflow to store an idea of where in the graph we are. So I'm going to begin a customer enrollment process. Whenever somebody fills out the form, they enter an email and whatever, we then go to the database, we save it in the database, and we say this is a brand new entity, but it's invalid, right? We can have a Boolean flag called invalid, I guess, or something, and we want an email, right? So string email. All right, so that's going to be one thing we want to say. And I want to let's just say we've got some sort of string that gets returned back to be able to further correlate. Okay, so we want to be able to do that. Log. Let's actually create a logger. Okay. Log.info. What do we want to return? Well, I guess we don't really need anything, do we? Right? We could just return a Boolean. What we're going to do is we're going to return the process instance ID. We don't need it. It's just nice to be able to observe it. Okay. So here's this, and we're going to say this dot that, and what customer ID do we want to have? Well, let's just say we've got a customer ID of 1, and the email will be email@email.com. This is not a real email, certainly. Okay, so now, at this point, somebody submitted a form, and they've got maybe it's a REST API with some JSON data in it. Maybe it's a form, whatever. We have a customer ID and an email, and we have an object in the database, presumably. So we're going to figure out what it means to start the process with those process variables in it in this method. And then finally, we're going to want to look up the existing tasks, because by that point, it'll have automatically progressed from here down to here. It's a user task now. There's a task list of outstanding confirm email tasks that are part of this process, right? In this case, there's only going to be one, and so you could say, okay, well, find me all the confirm email tasks for the customer whose customer ID we've provided. So how would that work? Well, we would say complete, complete confirm email. Okay, string customer ID. All right, so that's this, and I suppose we could, for ease of work, ease of reference, let's extract that out to a customer ID variable. Create that method. Okay, so there we go. There's my confirmation. Okay, we're going to confirm the email. Okay. Okay, so there's my confirm email. And this presumably happens asynchronously, right? This could happen. There's no reason this has to happen in the same thread or even the same application, because behind the scenes, it's going to get to a state in the database. It's going to get to the state. It's going to say, okay, I'm waiting on somebody to explicitly complete me. So I'm going to free up all threads. I'm going to write my state to the database, and I'm going to disappear. If somebody wants to wake me up and say it's been completed in a year, that's fine. But I'm not going to sit here and monopolize resources on the server waiting for that event. That'll happen later. And so we're, async. This is an async thing later on. Now, finally, once we've done that, actually, I guess at this point, what we want to do is we want to get all the tasks outstanding for this customer, and then confirm, right? So actually, how should we model that? I guess we could do that in this confirm thing. So really, that's all of it. And then we want to confirm that once that's done, that the component that we are charging with sending the email has some record of that. We want to see that it's passed through that. So let's say we're going to have a bean called email service, which will support a method that looks like this. Go down here. App service. And public void send string customer string email. All right, so there's that. And what do we want to do? Well, I just want it for my test here, my little example. I want to have a way of recording the fact that somebody has sent, has asked for us to send an email for that person. So I guess what's the easiest way to do this? I was going to store a list, but that doesn't really make sense. I mean, it could. Map string atomic integer sends equals new hash map concurrent hash map. Alrighty. And all we're going to do here is we'll say log, first of all. Okay, so there's that, and then we're going to say this dot, I think I want the full API, sends dot put if absent key it'll be email, and it'll be e new atomic integer. Okay, and then we say sends dot get email dot increment and get. Okay, so I'm just gonna increment a number there, and then work with it. Yeah, actually I could just, there you go. So that'll be there. That'll work no matter what. Now I can now poke at that state in my code up here just to confirm. So I suppose I probably could have written this in a unit test, but for now let's just see. Actually, we could do this in unit test. Let's do that in unit test. That might even be easier. So here, go to a test. Okay. And we're just going to use these. We're just going to inject them in a unit test here. Alrighty. Okay. And we're going to drive the test from, we're going to drive the flow of this process from a test, just as we did before, just as we were going to do before. But now I don't have to, come up with an excuse to write assert methods when I already got one, in a nice framework called JUnit. So I'll use that. And by the way, there's actually full-on unit testing support for Flowable as well, but I'm just using regular Spring Boot here. It's a little bit verbose, but hey, it'll get the job done. Okay, so we don't need this. We just want to have a little flow. Alrighty, so okay, good. So here we go. Let's try this out. So I'm going to say this will give us an ID, process instance ID. Great. Assert not null process instance ID. The process instance should not be null. Great. Okay. Oh, message is last. Okay. And finally, I guess we have to actually implement that. So let's do that. We've got the task service. So what does that look like? Well, we're going to use the runtime service. We're going to say this dot runtime service start process instance. I'm going to start it by the key. Well, the key is in the XML here. So it says sign up process. Okay, and I'm going to do so with some process variables, right? So I'm going to say I want to give it a map of data. Okay, so what is this assigned to? Get ID. Good. Okay, so that'll be the ID, that'll process instance ID basically. Now we're gonna give it some context, some variables that it will propagate. Those are the process variables that are unique to this process instance. So I'm gonna say map dot. Oh, I should have specified. Well, it doesn't matter. Let's just do this with Java. If I had specified Java 11 on the initializer, I would have been able to save myself a little bit of tedium here. But whatever. Vars equals new hash map vars dot put customer ID email, and I might even benefit from customer ID PV email PV email. Okay, and good. So there's that. Okay, that's our process instance. And we're going to provide those variables there, and those will be maintained along with the graph itself for the process instance. Okay, now, had I used Java 11, I could say vars equals new hash map, and I could have even used the new map.builder, map of, but I didn't, so I'm paying that price. Hopefully that should give you a reason to upgrade. Okay, so we've got now these easy to use constants. Private, static, final, just there you go, that's the same. Okay, there's my constant variables. So I'm going to begin the process. Let's see what that looks like. Before we get further down the line, let's just see what that looks like. Okay, so run. Alrighty. So I got the process instance. Above that highlighted line, it says process instance ID. So that worked good. So there's now a running process. Of course, it's H2, so just as soon as the application shut down, all the process state and all the data was gone because it's an in-memory embedded database, but you could use Postgres or whatever, or durable database. Okay, now we've got that. Now we are, by definition, at that state where we have those tasks. So here, we can use the process task service to do a task query to find where we have active tasks where a process variable called customer ID PV is equal to customer ID. Include that, and then get a list, right? Okay. And we could go a step further. We could say task name, and the task name here, of course, is confirm email task. So and what does that give us? Well, that gives us tasks. These are a list of task objects that we can poke at. We can say, okay, well, equals assert wrong assert. No kidding. Okay, so where did we put assert? There it is. Assert is I always get this confused. And the message is on the left. I knew that was a little weird earlier. I always get those confused. Okay, so now task claiming, completing. Now here, as you can imagine, we've got a bit of a race condition. I could claim this, but I'm not gonna. I could say, okay, first I want to confirm that tasks.size is equal to 1, right? Because we don't want to have more than one task, right? So there should be one outstanding. Actually, you could let's think about that. Let's say that somebody by accident started the sign-up process twice. And so now there's 2 different outstanding processes that have arrived at this state. Well, you should get them all and complete them. Absolutely. So you could say find everything by task name that's assigned to this customer, and then complete it. I know there's only one right now. So that's what I'm trying to prove. I'm trying to prove that we can actually let's do a better job. Assert true. There. We want to assert that it's greater than 1. Greater than or equal to 1. Okay, so let's try that. Okay, I've got something. So, task name, task ID, oh, that's the name. Okay, whoops. I think it's the task definition ID. That's the one I wanted. Let's see if that fails. Otherwise, I think it's I think the task name is the other string. Yeah, let's try it. Or I can just go back and do the right thing here. Okay, take two. That one failed. Let's try one more time. And then this goes here. Makes it more consistent anyway when I do that. Oh, there should be one outstanding. What do I have if not one? Let's see. Wonder if that makes a difference. No. Debug time. Tasks is empty. So, oh, I'm not sure if I need that actually. Did I? Let's see. Task name. Something like that. That should be fairly straightforward. Okay, there we go. That fixed it. So now we have gotten to the place where we have a list of tasks. Okay, and once we have a list of tasks, what we want to do is complete them. And so here we can use the task service to complete. Right. So get outstanding tasks. Now complete outstanding tasks. And you know, easiest way to do it is to say for each task, and we can now save some data. So we say this dot task service dot complete task ID. So there's the ID, right? You might also do this dot task service dot claim. Here you're gonna say I'm gonna task this ID is going to be claimed by me, J Long. or you could use the Spring Security Java Security Principal.get name or whatever, right? And then you would complete it, right? So, and the reason you would claim it is because you don't want somebody else in a sort of race condition. You know, you might have a pool of people, like in Amazon Mechanical Turk. You might have a pool of people looking at a screen where there's outstanding work to do, and they might start trying to finish the task that is out there while you're trying to finish it. So here you can claim it so that it's no longer accessible, nobody can take it, for example. Okay, and then once you've done that, what do we want to do? Well, at this point, once we've completed that, confirm that the email has been sent, because it's going to progress automatically from the task where it was waiting to the email task, and it's going to then end up at the end event. So we should see it'll automatically go from the completion of this all the way down to the end immediately, right, in the same transaction, in fact. So we go now to our test one more time, and we're going to inject our email service, which wasn't much of an email service at all, really, was it? So auto-wired private email service, and we're going to use email service just to confirm assert. And again, this is one of those things I could probably have done with mockbean. This dot email service dot sends dot get and what do we say the data was being stored as? Email service customer ID. No, it's email. Okay, it's email. So we are going to confirm that this email is a key. Okay. Cert equals email dot get 1. Okay, that should be the same. And that's it. That should be the whole process. Let's try and run this now. There we go. Look at that. So we have now started the process instance. We sent the welcome email. You can see it printed that out, and now it's shutting down. Right? That's the whole thing. The whole thing is done. And at this point, even if I wanted to find that data, I couldn't. Right? That process has been executed. It's not deleted. If we had MySQL or Postgres or something durable, we could log into the tables and we could see that data is still there. And indeed, we could even inject the process engine, for example, private process engine. Or we can get the history service, right? And we can use the history service to say, okay, well, let's create a historic process instance query where I can search for process, variable value includes, customer ID equals to 1, right? I could do that, and I could look at the old processes, but it's no longer a current on active process, so you have to find it through the history service. So this is just the beginning. We've only looked at just the smallest bit of what this API can do. Workflow solutions are great for long-running tasks in which you must involve both humans and autonomous agents. You can see it embeds nicely in a Spring Boot application, but there's so much more to this than what I've shown you here, and so it's for this reason that big customers are flocking left and right to buy the Flowable product, because it gives you identity management, it gives you integration with enterprise, it gives you a whole bunch more than just these pieces here, right? You get an actual fully fledged server that you can use to solve these problems, solve kinds of document management problems, to solve these kinds of things beyond what I've shown you here. I hope you got something out of this, and obviously I really do hope I can do another video on this or something. I mean, I just feel like the case stuff is so cool. That's a fairly new feature. There's been so much that's happened in the last couple of years. It's now a 300 person plus strong company that powers this, that drives the engineering work on this. So it's moving very quickly. It's an amazing group. I'm just very eager to see where things go. I think this has more relevance in the world of microservices than ever before, and it certainly has relevance in a world where things are more complex than ever before. So I hope you got something out of it. As always, I want to thank you for watching, and we'll see you next